Hey, ladies and gentlemen, 17.1 equation of a circle, geometry. All right, so we've played around with a lot of circles lately, and it's about time we start getting some equations for them. Let's see, the essential question: how can you write the equation of a circle if you know its radius and the coordinates of its center? Well, the answer: the equation of a circle with a center h comma k and a radius r is x minus h squared plus y minus k squared equals the radius squared. So basically what's going on here is you have a graph of a circle, okay? Your center is given by a coordinate, and then they tell you what the radius is. Now, the thing about this equation is the h really does the whole left or right concept. So if h is positive, it shifts your circle to the left, or the center of your circle to the left, therefore the entire circle. And if your h is negative, it shifts it to the right. Okay. Now your k, on the other hand, okay, your k actually does the whole up and down type business. So if k is negative, it'll go up, and if k is positive, you'll go down. So the reason why is because same reason when, remember back in algebra, graphing absolutes or quadratics, and you had like vertex form, or for absolute values you had like x minus 2 plus k or something like that, and the minus 2 would actually make it go to the right 2, okay? And same thing with quadratics, you had x minus 2 squared, something plus k, and it would just move you 2 places to the right. Same kind of business happens with the h and k because they're being squared. Okay, so that's just something to note, and you will play that with Desmos. So, real quick. All right, I'm back. So again, it's always the opposite direction. If it's positive for your h, you go to the left. If it's negative for your h, you go to the right. If your k is a negative, you go up. If k is a positive, you go down. So it's always like the opposite direction with circles. It's all counterintuitive. Let's just say it spins you around. All right. So definition: a circle is a set of all points in the coordinate plane that are a fixed distance r from the center h comma k. So as you can see just by looking at the pretty picture, we have our center, and then we have a radius to deal with. So those are the two things you need to know in order to be able to graph a circle. Its center, where is it centered at, and what's the radius? And that's actually, I kid you not, in astrophysics, that's actually a big conversation piece on trying to figure out the gravitational pull of a planet. Because if you're flying through space in a spaceship, and you're passing and trying to get to Europa, well, guess what? Jupiter's right there, and that sucker is huge, so huge that its own gravity just kind of messes up the direction or the heading of your spaceship. So you kind of have to factor that in. And guess what? NASA, they'll find the center, they'll look at the center on a telescope, they'll measure the radius, and then they try to get light spectrum analysis to basically say, like, this is what the planet's composed of, and this is the mass of it. And then next thing you know, they plug into a formula, and then therefore they find out how much gravitational energy it has, so they factor it in. And guess what? They're right. So they actually use this math. I mean, don't get me wrong, this is high school level, but this is actually how they start off. Where's the center? Measure out the radius. Done. Okay? All right, the equation of a circle. The equation of a circle with the center, again, we need a center and a radius, and radius r is x minus h squared plus y minus k squared equals r squared. So, for example 1, and this is how your homework does it too. You get your center, and that's good to know because now you have to substitute in your center And as you can see, they did that. Notice how they're aware of the double negatives going on right here, right? Minus a -2. Okay, the 5, then nobody really cares about the 5. They're just like, oh yeah, you just slides in -5, done. Okay, so they automatically took care of the minus +5 or -5, +5. It took care of it. But the radius, okay, the radius is his own little conversation piece. Okay, it's kind of like, yeah, I see the planet, but how big is it? Well, we need to find the radius. Okay, so the radius is like part of the conversation now. So they're just going to plug it in for r, so you got 3, okay, being squared. So eventually what happens is they square the 3, they get their 9, okay? And as you can see, they took care of the double negative, okay, which is a positive, and y minus 5 squared just comes down. And they simplified. That's our equation. We have an equation that will graph us a circle. Don't believe me? Create a table, okay? And if you create a table and you graph it, it'll turn into a circle. And don't worry, you'll have some practice graphing as well. And we'll get there. So again, the two things you need to have is the center and the radius. All right, your turn. Radius is square root of 5. Now don't freak out, because we all know, or should know, that when you have a square root, some number being square root, okay, and then you square it, it's just going to equal whatever the number was on the inside. Okay, so don't freak out if your radius is a radical. Okay, he's radical. Yeah. All right. So again, substitute, and then just go ahead and square the square root of 5, and you'll get your equation. So this is your turn. So let me know once you have your answer, and yeah, it should be all right. Buddy time. What information do you need to know to write the equation of a circle? So I'm going to go ahead and draw a stick. And yeah, at the end of class, I'll just call one of you guys up and just explain to me what your answer is for this question. All right, graphing circles. This is the pretty part of it all. And if you're interested in Algebra 2, they go into this a little bit more in detail. So basically, remember, what are the two most important things to know about a circle? Well, the center, it looks like it's there. If you're not sure, you can always count the diameter. Like, I got going across, I got, see, 1, 2, 3, 4, 5, 6, 7, 8. I have a diameter of 8. And 8 divided by 2 is my radius, which is 4. Okay. So that's good to know. In fact, let me use a better... There we go. So it looks like my radius is 4. And therefore, it looks like my center, as you can see, it looks like target practice, right? And it looks like they're focused in at 0, 0 for my center. So now that I figured out the two things that I need to know, I can make my graph. So remember the graph, the equation is x minus h squared plus y minus k squared equals my radius squared. Now my radius, r, is 4. So that's good to know. Don't forget I'm still squaring him. My y minus k is that value right there, and h is that value right there. And, well, what's y minus, 0, right? So it's just y. But I'll write it out for you, okay? It's a good habit. And then h is 0, so... And that's a terrible 0, I know. All right, so x minus 0 is just x, and it's being squared, plus y minus 0, which is being squared, and that's just going to be y squared. And then 4 squared is just 16. So as you can see, I just created a function, or an equation of a circle, from the graph. Okay, so again, the biggest things to note is what's my center. Find your center. And your radius. How big is this thing? Okay. Example 2. Apparently I decided to give you more examples. Awesome. Okay. Let's say my center, and I'll make it up as I go. Let's deal with, let's deal with double negatives. Yeah. So double negatives. So my center is at -3, comma, -2. Okay. And my radius, if you ever want to know how to draw a circle, I kind of do this. My radius is 2, so I kind of go out and do this little like targeting thing, and then I just try to connect them perfectly. Doesn't always work, but sometimes it does. Sometimes freehand sometimes works. But again, I'm not grading you on how perfect your circles are. Dang, that'd be awesome if they did that in college. Dang, they never did that for me. That would have been an awesome class. All right, so again, it looks like my center is at -3, comma, -2. That's good to know. And my radius is 2 units. Okay, so let's go ahead and create my equation. Again, x minus h, and h is -3. And then I'm squaring all that, plus y minus whatever my k is, which is my -2. And I square all of it, equals my radius, which is 2, squared. Let's see. X minus a -3 is really just x plus 3. And that's being squared, plus y minus a -2, which is negative times a negative, is a positive. In this case, +2, all being squared, and then 2 squared is really just 4. Okay, so as you can see, from the graph, I derived an equation of my circle. And it works that way. So if you remember, like parent functions, your center was originally at the origin, right? And then they ask you, well, what changed? You moved 3 spaces to the left, and that's this right here, right? Remember, when it's positive, it goes the opposite direction, so it goes 3 to the left. Okay. Sorry, let me erase that. I don't want to confuse you on that one. So remember, that takes you 3 to the left, and then your k, see, you went down 2. Okay, so you go down 2 because your k is positive in the equation. All right, so it always has the opposite direction heading. So just remember, it's always the opposite. Okay. All right, your turn. I want to go ahead and try this to you. I want to go ahead and I want to give you a center, and I want to go ahead and make this a little interesting. There we go. Pretend it's a perfect circle, okay? I decided to kind of wing it, okay, on this one. But pretend it's a perfect circle, okay? What's my radius? And again, go to the nearest square unit on that one, okay? I'm not trying to give you like some crazy decimal, okay? What's my center? What's my radius? And then just set up the equation and let me know what you got, all right? All right, your homework, it's very chopped up. The reason it's chopped up is because there are certain elements that we aren't really testing you on. I had to kind of make sure I didn't waste your time and your time is spent more efficiently. So pay close attention to what I'm indicating. Page 896 through 898, numbers 1 through 2, 6, 15 through 16, and 19 through 23. Okay, so if you have any questions, just let me know. Good luck.